In this video, we're going to talk about 2.2 Objective 3, where we estimate limits from a table. We've been doing this idea already. Let's go ahead and let's simplify this limit before we get started here, because this is x plus 5, x minus 5 over x minus 5. We can cancel those and say this is the limit as x approaches 5 of x plus 5. I'm not going to evaluate that analytically. So that is going to be the answer here of 5 plus 5 is going to be 10. But I'm just going to stick 4.9 in here. Plus 5 is going to be 9.9. This is going to be 9.99. This is going to be 9.999. 9.9999. This is going to be 10.1, 10.01, 10.001. 10.0001, and you can see that as I get closer and closer to 5 from either side, I'm getting closer and closer to a y value of 10. Okay, this is going to be some funky factoring for you, but this is square root of t plus 10 times the square root of t minus 10 over the square root of t minus 10. So this is limit as t approaches 100 here is what we're probably looking at. This is going to be root t plus 10 as long as t is not 100. So we're getting closer and closer to that. Use your calculator to approximate these values here to 4 decimal places. So this is going to be 19.9950. And then this is going to be 19.9995. And this one is going to be 20.0000 degrees to 20, within 4 decimal places. And on this side, we get 20.0050 and 20.0005, and then 20.0001, and we're getting closer and closer to 10 plus 10 is 20. That limit exists. Ooh, this is a fun one. All right. 1 plus x to the 1 over x. And we're going to get close to 0 from the left and the right and see what happens here. And this is going to be, again, use your calculator for this. You're not going to be able to do this analytically yet. So this is going to be 2.70481. We're going to go out to 5 decimal places here. 2.71692. 2.71815. 2.71827. Then on the other side here, we have 2.73200, 2.71964, 2.71842, and 2.71830. It is squeezing in on the value of E, which we can estimate that as 2.71828. But the exact value is that irrational number E. So that's just an important limit to memorize for you to know that one. We can write it a couple of different ways. It can be this limit here. We can also write it the limit as x goes to infinity of 1 plus 1 over x to the x. That will also go towards e. We can write it this way. Also go towards e. Why do we care about that? If you look at this one, it might look like something that you've seen in compound interest formulas, where a equals p times 1 plus r over n to the nt, and n is getting, as n gets bigger and bigger, then this is basically infinity, and that's basically infinity, and that basically doesn't matter. And all of a sudden, we'll talk about this more later, but this is going to become p e to the rt. Where did that e come from in continuously compounding interest? It came from this limit up here. We'll talk much more about that limit later in calculus, but there you go. There's a little bit of an explanation of something there. All right, let's go ahead and find this limit here. We can do it by factoring. So right now this is x minus 1 times x squared plus x plus 1. This is 18 cube root of x minus 1. I'm going to have to break that up now using the difference of cubes formula. So this is the cube root of x minus 1 times the cube root of x squared plus cube root of x plus 1 times x squared plus x plus 1. These will cancel. It's these limits that are equal. I need to not forget to put my limit symbol in there. Limit as x approaches 1. Limit as x approaches 1. So when I do that, I have 18 over, this is 1 plus 1 plus 1 times 1 plus 1 plus 1 is 18 over 3 times 3. 18 over 9 is 2. Now you could have done that using a graph. I didn't. Let's go ahead and see if we can work some magic on this one. And I'm only going to do 1 or 2 more here. See if I can multiply by the conjugate of this thing to, let's see what happens here. 2 minus 1 is 1, minus 1 is 0, 1 minus 1. So let's, yeah, let's analyze the graph of that thing. So stick that into your graphing calculator and look at what happens as x approaches 1. Use your table in your graphing calculator to see what happens. And you're going to see that it approaches probably 5 1/3. It's probably more exactly what it approaches, but we're going to round to the nearest hundredth and say that it approaches 5.33. And then let's stop with this one here. Again, use a table for this one, stick it into your calculator, and see what happens as you get close to 8 from both sides. So 7.9, 7.99, 7.999, 8.1, 8.01, 8.001. And you're going to see that you're going to get closer and closer to 5. We'll stop there. We'll come back next time and we'll talk about 2.2 Objective 4. See you for the next video.